when it comes to right away arriving at the final product, but as I said, not at the expense of knowing the entire mechanism. This is how you right away write for the dehydration product of the corresponding aldol. Let's move on and look at a few more cases that feel more confident about the mechanism and the terms which I have introduced to you. So after ethanol, we move to the second or the higher carbonyl, which is propanol. CH3, CH2, CHO, yet again ROH minus base catalyzed, loss of H plus will make sure that the hydrogen I am abstracting is always the alpha hydrogen. So the conjugate base I get is CH3, CH minus, CHO, and this would act as a nucleophile to the next molecule. Now in course of carrying out more aldol condensation, you realize that essentially it's about 2 moles coming together, 2 moles getting involved in condensation, where one of the molecules would be losing alpha hydrogen. Please be attentive. One of the molecules will be losing alpha hydrogen, will be generating the nucleophile. So one half of the aldol would certainly be about the molecule which lost alpha hydrogen and generated the nucleophile, and the other half of the molecule would be the one which accepted the nucleophile. So we should be able to visualize the 2 molecules as one which is acting as the acceptor. I hope you don't mind me calling this molecule as the acceptor, because this is accepting the nucleophile and this is the one generating the nucleophile. Yes or no? And then you'll want to keep it simple. CH3, CH2. Allow me to skip a small step here. Instead of the alkoxide, after the attack of the nucleophile, right away I'm assuming plus water minus OH minus. Allow me to skip a step. Instead of the alkoxide, and people are actually not allowing me, so maybe I'll carry on with all these steps. CHO minus, it's the alkoxide, and I'll want it to be attached to the alpha carbon of another molecule, and then plus H2O minus OH minus would be about regenerating OH minus, which could go and attack another molecule, so it's base catalyzed eventually, and this would mature to CH3, CH2, CHOH, CH, CHO, CH3. Now see yet again, I've got a beta hydroxy compound, I've got a beta hydroxy carbonyl, yes or no? Now over a period of time, what I want you people to start interpreting is, when you look at a beta hydroxy carbonyl, when you look at this aldol, you start identifying this part of the molecule has come from the molecule, this part of the aldol has come from the molecule which has acted as the acceptor, Certainly the carbonyl carbon of the molecule which acted as the acceptor is going to mature to the alcoholic group. Yes or no? Yes or no? Small little thing you want to take note of. And eventually when you look at an aldol, first of all, when you find a beta hydroxy carbonyl, it might very well be an aldol, and then the carbon which has matured or which is bearing the OH group must have come from this part of the molecule, must have come from the molecule which acted as the acceptor, and then you find that this carbon which has come and attached itself is from the molecule which acted as the nucleophile generator, which lost alpha hydrogen. And because this carbon which is maturing to an OH group acting as the acceptor will always accept the alpha carbon of another molecule, it's not coincidental but evident that every time with respect to this carbonyl, this OH will be beta hydroxy. I repeat, this carbon bearing the OH which has come from the carbon acting as the acceptor will always attach itself to alpha carbon with respect to the molecule which acted as the nucleophile. So every time with respect to this carbonyl, this OH will be beta position. I hope you are figuring it out. And so many times I repeat, it will help, where instead of going through the entire mechanism and finding the product out of the 4 options given, you are able to identify. Chances are in a given you might just have one compound which is a beta hydroxy compound, and right away if you stick to these terminology, if you know these terms, you will know that an aldol is always going to be a beta hydroxy compound. So it would be of great help, not only in cross checking whether you have done the mechanism all right, whether you have drawn the correct aldol or not, but so many times you will be able to identify an aldol just by knowing it's a beta hydroxy carbonyl. I have already told you why every time it's going to be a beta hydroxy carbonyl. Fine. And there is going to be a tendency for this molecule to lose water. So this small heating, slight heating, would lose water, forming CH3, CH2, CH, and you'll want to place the double bond such that it's always in conjugation with the existing carbonyl group, and you're always supposed to draw for the alpha beta unsaturated carbonyl. You're always supposed to draw the alpha beta unsaturated carbonyl. Yes or no? ठीक है? So this is going to be the dehydration product of the corresponding aldol of propanol. Dehydration product of the corresponding aldol of propanol. And for those who will always be happy, finding a shortcut, yet again, you'll want to bring 2 moles of propanol together. So see what I do? CH3, CH2, CHO, and I'll make sure that the hydrogen I'm using of the second molecule is always the alpha carbon hydrogen. Yet again, I could bring the 2 close together, take out a mole of water. I can already see some happy faces, praying that in the exam it's only about drawing the final compound and not the intermediates, but as a matter of fact we'll want to know all of it. So you'll be able to draw for the dehydration product of aldol right away. Okay? Now we saw a couple of cases for carbonyls, for ethanol and propanol. Then we understand it's going to be beta hydroxy carbonyl and then an alpha beta unsaturated dehydration product every time. So you would have copied all of it. All of you have copied all of it. Maybe very quickly we'll want to extend it to the simplest ketone. So tell me, which is the simplest ketone? Yes, please. Propanone, also called acetone. You see, some of you are so reserved that either ways, when you're not able to come up with a reply, or so many times you'll be just smaller attitude, you'll not want to respond. So which is the simplest ketone? Acetone. And let me get back to our usual symbolic forms, so it's convenient for both of us. Acetone, now 1 mole, I'm going to need more space for acetone. So beginning with the first mole of acetone, and the first step, which certainly is going to be yet again loss of alpha hydrogen, generating this enolate, and yet again I would want to write for the resonating structure, realizing C minus being more nucleophilic than O minus, this form or this resonating structure will act as denucleophile. Yes or no? So the same approach on a different molecule, and for a ketone I get the corresponding enolate. Then I am supposed to draw for the second molecule which I expect to act as the acceptor. This molecule should act as the acceptor. Fine. Maybe I'll give you time to copy all of it. You'll want to just look and agree to all these steps. I'll give you enough time to copy down. But the first molecule has generated the nucleophile. I'm writing for the second molecule which is going to act as the acceptor. I'll let this act as the nucleophile and attack the second molecule at positive carbon again. Now this again is going to be the slower the determining step, and I'll get, now maybe this time you can allow me to skip one step. Now you can allow me to skip a step. I'll want to right away write for the alcohol. I know an alkoxide will take H plus from water. So it's going to take H plus from water. And now I'll want to draw for the aldol right away. So this O minus would mature to an OH, and this will be attached to the alpha carbon of another molecule. See, yet again what I find is a beta hydroxy compound. What I get is a beta hydroxy compound, yes or no? So this would be the aldol of acetone. This would be the aldol of acetone. I've got a beta hydroxy compound. Willing to lose water, undergo dehydration. And certainly going to produce this as the alpha beta unsaturated carbonyl, alpha beta unsaturated carbonyl. So even for a ketone, you know, carrying on the same steps, which is loss of alpha hydrogen nucleophilic attack, taking H plus from water, I could draw the beta hydroxy compound which will undergo dehydration to form alpha beta unsaturated product. For acetone the process will not stop here. For acetone the process will not stop here, it will carry on with third mole of acetone acting as the acceptor. But before I go into that, what's this compound called? Very popular name. What's this compound called? This alpha beta unsaturated dehydrated product of the carbonyl of the aldol of acetone. Yes, please. Croton ketone. So if that was croton aldehyde, this is croton ketone. Now here's the point, you know, in ethanol there was croton aldehyde, so he feels it should be croton ketone. That's again debatable, but pretty debatable. We have a valid point, you know. If you call that croton aldehyde, why not call it a croton ketone? So we'll think about this nomenclature. We'll you know, it's certainly a debatable point, but so far, you know, no one has called it croton ketone. So till date it's called methyl oxide. Methyl oxide. Although, you know, personally I find croton ketone is pretty alright, but it's called methyl oxide. And I repeat, all the names which I tell you, all the trade names which I tell you in this topic, you'll want to recall all of it. Methyl oxide. And I told you the process will not stop here. For acetone, it's going to carry on involving third mole of acetone. With this, it's going to lose alpha hydrogen. With this, going to lose alpha hydrogen. And if that loses alpha hydrogen, this will be the corresponding enolate. This will be the corresponding enolate of acetone. And I'll take third mole of acetone. Where this third mole of acetone, you know, would be acting as the acceptor. Third mole of acetone will be acting as the acceptor. So this acting as the nucleophile will attack this new mole of acetone at this positive carbon. And yet again, allow me to skip a step where I'll want to write this O minus directly as the alcohol. Fine. It must be very, very obvious till methyl oxide. and then I want to take away an alpha hydrogen from methyl oxide and form a nucleophile, the enolate which will attack the third mole of acetone, and then the beta hydroxycarbonyl I'll get should look like this. OH here, double bond O, double bond here, and yet again it's a beta hydroxycarbonyl with respect to this carbonyl, the molecule which was acting as the nucleophile. Yes or no? Yes or no? So many times people fail to respond because they're busy copying. I told you I'll give you enough time to copy down everything. Some of you have a very periodic rhythm of copying down things. I mean, your head is always going to move like you'll look at the board and then you'll copy down, and you'll look at the board and you'll copy down. And believe me, this motion is completely completely unaffected by what I'm saying. It keeps on at the same pace. It's true for some of you. I'll not want to name right away, but I'll tell you, I'll give you time to copy down. I want you to focus on what I'm doing right now, but you're going to keep on carrying like this. Carry on keeping like this. And when you stop, I know now I can speak. So far so good. I hope you're not reluctant at looking at the board, realizing that what's the point looking at the board now? I have it copied down already. I have my notebook and I could look at any day. So we just carried on with the mechanism one more time. For acetone, you'll want to keep in mind it's going to involve 3 moles of acetone, and this is going to be the second aldol formed. Should undergo dehydration, and this undergoes dehydration. To give you, maybe I'll just want to buy some space here only. You have copied all of it, so I'll write for, and maybe I'll want to give you a bigger view also. So this is going to mature to the dehydration product of this kind. Such a nice, good looking structure, symmetrical structure. Fine. But again, you'll want to put a pi bond which can resonate with C double bond O. And what is this compound called? Anyone? What is this compound called? See if you've ever heard of furon. It's called furon. Heard of it? Heard of it? Now, if they have taught you aldehyde ketones in school, which they are expected to do by now, such an important compound, such an important trade name. It's called furon. You'll want to know how methyl oxide looks like, you'll want to know how furon looks like, and you'll also want to know how all of this is shaping up. Now, some of you who are now still waiting for the shortcut which I'm about to tell you to draw the final compounds. Some of you are very innocent and very honest about it. Right away you display your feelings, your emotions. So a shortcut of drawing the methyl oxide and furon is going to be, this time you'll want to bring 2 moles close together. See, 1 mole of acetone here, another mole of acetone here. Make sure you're using these 2 hydrogen atoms. Take away water, and this to this is right away writing for the dehydration product. Use a carbonyl oxygen, use alpha hydrogen. Okay? Is how you draw the methyl oxide one. And as far as furon is concerned, again such a symmetrical structure, you could right away draw for it. by bringing 3 moles together. See how you draw for furon right away. You'll want to bring 3 moles together, 1 carbonyl here, 1 carbonyl or 1 acetone here, 3rd mole of acetone here, and this time you'll want to use these 2 hydrogen atoms and these 2 hydrogen atoms. See if you understand. Take out water from here and from here, place corresponding double bonds, and if you add all of it, if you add 3 of it this way, you'll arrive at the structure of furon. But by and large, I'll want you to know the mechanism and all of it. Fair enough? When it's done by me, believe me, when I'm doing it for you, we kind of know each other by now, I go at a pace which is convenient for you. You're used to my language now. So chances are when I'm doing it for you, it would look, chances are it should look pretty much within reach. But I've said in the past, it's all about doing it of your own. You'll want to do it a couple of times or more number of times at home and feel very confident and very comfortable with arriving at the structure of beta hydroxy compound and the corresponding alpha beta unsaturated compound. I repeat, there should be no compromise as far as the mechanism of condensation reactions are concerned. Absolutely crucial for our scheme of things. And I'll give you some compounds randomly. Maybe you'll want to leave some space in your notebook. Try out the mechanism at home. I've done it for any cyclic compound so far. The same is going to happen if it's a cyclic compound. Believe me, 2 moles of this in dilute alkali is supposed to give you initially a compound of this kind, and then it's going to get dehydrated to a dehydration product of this kind. I'll want to leave some space in the notebook, exactly carry out the same steps, take out alpha hydrogen from one molecule, make it attack another molecule as a nucleophile. And as I said, you'll want to leave some space in the notebook and carry out all these steps in great details of your own. Now moving on. Two butanone, 2 moles of it, dilute base. It's going to help if you carry out a few mechanisms of your own. Find the aldol minus water, find the dehydration product, the alpha beta unsaturated compound. Leave space in your notebook, and as I said, you will want to try these mechanisms of your own. Actually, the same mechanism on different compounds. And so far, we have been talking of individual molecules, individual compounds, and the mechanism proceeding to the aldol and the dehydration product. Now let's take up a few more variations. So this time we have a mixture of carbonyls. You have like CH3CHO and CH3CH2 CHO, and to the mixture of carbonyls you add dilute OH minus. Now the question is, how many products are possible? How many products are possible? Okay, we will draw all the 4 products. How many products are possible? 4 or 3? Repeat if you subject a mixture of carbonyls to dilute base. Alright, you can take your time, maybe I'll give you enough time. Doesn't matter whether you'll directly write to write for the product or you'll want to carry out with individual steps. I'll leave you with one more problem. So it's a mixture of benzaldehyde and CH3CHO with dilute OH minus. So both for problem 6 and 7, tell me the number of products and I'll want to explain it for me. Take your time.